Now let's further study about electromagnets. These electromagnets are basically created by the electric current. As the name suggests, it represents the magnet which are created by the flow of the electric current. How the electromagnets are formed? The electromagnets are basically formed when the soft iron rod is placed inside the solenoid. This is your soft iron rod which is called the core. Okay, now we are going to wrap the insulated copper wire around it and it behaves as a solenoid. Okay, so this is the insulated copper. We are going to wrap it in this way. Now it is connected to a battery. Now just see, when it is connected to the battery, then the current is passed through it. Okay, from positive to negative. When the current is passed through it, then this would be the direction of current. Now, what we are going to see, that the magnetic effect created in the case of electromagnet, the magnetic effect created by the electromagnet is strong in comparison to the solenoid that we have discussed. Why? Because in this case, the magnetic effect which is created is due to the combined action of the solenoid as well as the soft iron core. In the case of solenoid, we use only the turns of the copper wire. From that, the magnetic effect is created. But here, the magnetic effect is created by the copper wire also and by the soft iron. So, the two gets add up and makes the stronger magnetic field. Okay, so this is your electromagnet. Now, if we use instead of soft iron steel, then this steel produces the permanent magnet. That is, when you switch off the power supply or when the current does not passes through the steel which is placed inside the solenoid, then also it behaves as a magnet. It is the property of the steel that it will retain the magnetism effect even if the current does not passes through it. But the soft iron core loses its magnetism as soon as the current stops flowing through it. So, in the case of electromagnet, because these are temporary magnet, we use only soft iron core. Now, how to find the polarity in this case? This is how the current is flowing. Now, if you look the current from this side, this is the side from where you are looking the current, then you can see that the current is flowing in anti-clockwise direction, opposite to the direction of the clock. So, we have already discussed that when the current flowing in the coil in anti-clockwise direction, then that phase represents the north polarity. So, this phase represents your north polarity because the current flowing in the anti-clockwise direction. Now, come to this side. If you are situated here, okay, and you are looking to this electromagnet, then you see that the current which is flowing in clockwise direction. This is how the current is flowing in clockwise direction. So, the clockwise direction represents your south polarity. Like we have seen in the solenoid, the electromagnet strength also depends upon the three factors. The first factor that we have already talked about, the number of turns. That is, larger the number of turns, more will be the strength of the magnetic field created by the electromagnet. Second is the current. If the amount of current flowing in this electromagnet is large, so the strength of the magnetic field created is also very large. When the current reduces, then the strength of the magnetic field created in the electromagnet also reduces. Third point is length of the air gap between the poles. What do you mean by this particular line? This line shows that larger the gapping between the polarity, the less will be the magnetic field created. And smaller the length of the air gap between the polarity, the more will be the magnetic field created. How? Suppose this is your bar magnet. Okay, the bar magnet has two polarity, the north polarity and the south polarity. Now see, the distance between the north polarity and the south polarity, if we talk about the outside term, then the air gap, that is the air around the north polarity and the south polarity, is high. So that means the strength of the magnetic field created by the bar magnet is less. Now let's take the another magnet, that is horseshoe magnet. Okay, it is also called as U magnet. This is also a magnet. One end of this magnet represents the north polarity and the other end represents the south polarity. Now you see, in comparison to the bar magnet, the length of the air gap between the two polarity reduces. That is, these two polarities come at closer distance as compared to the bar magnet. We are not talking about the distance inside, we are talking about the distance outside. Okay, so in this case, the air gap between the two polarity north and traveling towards the south is large. And in this case, the air gap between the north and the south polarity is less. So, it is inversely proportional to the magnetic field. If the air gap is large, the magnetic field is less. In this case, the air gap is small, so the magnetic field is large. So these are the three parameters on which the strength of the magnetic field created by the electromagnet depends upon. Now let's see the differences between the permanent magnet and the temporary magnet. If we talk about the temporary magnet, then we are talking about the electromagnets. The electromagnets are basically temporary magnets. Now what happens that the temporary magnets mean that it will retain the magnetic effect as long as the current is passed through it. It loses its magnetism as soon as the current withdraws from it. On the other hand, if we talk about the permanent magnet, then we are talking about the bar magnet. That is, it does not get affected by the passage of the current. It will retain its magnetism even after the current is withdrawn from it. The second point is that in the case of temporary magnet, you can alter the polarity according to it. How you can alter the polarity? You can change the polarity of the battery. If the polarity of the battery is indicating positive and negative, then the poles representing north and south. If you have to change the poles, that is, you have to change the pole from south to north. That is, you have to turn the battery to other side, that is negative is this side and positive as that side. So by changing the polarity of the battery, you can change the polarity of the magnet. But it is not possible in the case of permanent magnet. The permanent magnet are designed such that they have the fixed polarity. You cannot change the polarity even if you want afterwards. The third point is that the strength of the magnetic field can be altered in the case of temporary magnet. I have already told you that there are three major points by which the strength of the magnetic field depends upon, that is number of turns, the current and the length of the air gap. But it is not possible in the case of permanent magnet. Whatever will be the strength of the permanent magnet, it will remain fixed. You cannot alter it. The strength of the magnetic field in the case of temporary magnet is high because it is created by the combined effect of the solenoid and the soft iron core. While in the case of permanent magnet, the strength of the magnetic field is weak as compared to that of the electromagnets. So these are the basic difference between the permanent and the temporary magnet.